Hey guys, in this video we're going to talk about arcs and sectors. An arc is part of your circumference, so here this part in red that I'm labeling there, that could be an arc, it's this line. And a sector, so here for example the one that I've shaded in here, is part of your circle. It's like a slice of cake, but it's got to have two radii in it, so it's got to go to the center of your circle and it's got to be enclosed by an arc. Okay, and if you had a shape like this and you weren't exactly sure which one you were asked for, so did they want this arc here or did they want this arc here, the smaller one would be called the minor arc and the bigger one would be called the major arc. And the same for the sectors, so if you got given this sector, the shaded one in here, this would be the minor sector because it's the smaller one, and you could have a bigger one here and this would be the major sector. Okay, like that's a major slice of cake, that, isn't it? So to get us thinking about how to work these out, let's have a quick look at these shapes here. So the question is, what fraction of the shape is shaded? You might be able to look at that and tell me straight away what fraction is shaded. First one here, we've got half of it is shaded. Here we've got a quarter of the circle is shaded. What about this one here? We've got 3/4 of the circle shaded, and here I've got 1/3 of the circle is shaded. What about this one? Now I know that angles around a point add up to 360 degrees, and this sector here has 80 degrees out of the full 360 degrees. So we could say this fraction of the circle we've got here is 80 out of 360. That's the fraction of the circle that we've got. The same for the next one here. I've got 100 degrees out of a total of 360 degrees. Okay, so the way that we work out the arc lengths and the areas of sectors is to think about the fractions of the circle that we've got. So if, for example, if I was given this one here, if I wanted to know this arc length here, well, that arc length there, well, it's a quarter of a full circle, so this arc length here will be a quarter of a full circumference. Or if I wanted to know the area of this sector, I've got a quarter of the whole shape, so I'll have a quarter of what the area would be for a full circle. Okay, so let's have a look at some examples. In fact, before we do that though, you might see these formulas here and it looks really confusing. So to be honest, I prefer just to do it without the formulas because it kind of makes sense. But if you want to just quickly have a look at this, you look there, we've got the fraction of the circle that we've got out of 360 degrees multiplied by the area of what a full circle would be. That would give me the area of a sector. And again here I've got the fraction of the whole circle, but this time multiplied by 2 pi r or pi d there. That would be the circumference, wouldn't it? So it's just a fraction of the circumference for an arc length. So let's have a go at the questions. Let's have a go at this one first. So it says, what is the area and the arc length of the minor sector? Well, let's do the area first. So I've got here 80 degrees out of a total of 360 degrees. So I've got 80 out of 360, and I've got that fraction of the whole area. So this is here, we're doing area first. So I'm going to multiply that by pi times r squared. So r is 3, so pi times 3 squared. And I recommend you do this on your calculator and see if you can type it in the same, get the same answer as me. So I get an answer of 2 pi, or that makes 6.28 centimeters squared, because it's an area. Okay, I've rounded it there to 2 decimal places, haven't I? Right, what about the arc length? So the arc length of the minor sector, so that's this length here. So again, I've got, let's write it here, arc. I've got 80 out of 360 degrees, but I've got that fraction of the circumference. So the circumference is 2 times pi times r. So r here is 3. So I'll type this in my calculator. What do I get now? I get 4/3 pi. So that is 4.19 centimeters if I round it to 2 decimal places. Okay, try typing that in your calculator, see if you get the same answer. Let's try this one here. Very similar. In fact, why don't you have a go at it first, pause the video and see if you get the same answer as me. So area, I'm going to do 100 out of the 360 multiplied by pi times the radius squared, so pi times 2 squared. Okay, I get 3.49 centimeters squared. Right, if I'm doing the arc length, so this arc length here, so again I've got the fraction of the circle, 100 out of the 360 degrees, this time times 2 times pi times r for the circumference. So that gives me 3. That's funny. Gives me the same answer. But this one's in centimeters, isn't it? Okay, it's not in centimeters squared. So this one is the length, and that one is an area. Okay, I've rounded it to 2 decimal places. Right, the next one. We've got again, what is the area and what's the arc length of this sector? So for the area, well, in fact, pause it, have a go, and then I'll show you how to do it. Okay, so the area is, so I've got 60 degrees out of the 360. I'm going to multiply that by pi times r squared for area. So 5 squared here. That gives me, let's have a look. Okay, that gives me 13.09 centimeters squared. And the arc length, so the arc length here, that length there, is again 60 out of the 360 degrees, but it's that fraction of what the total circumference would be, or total circumference. So that would be 2 times pi times r, and r is 5. So that gives me 5.24 centimeters. Right, and the last example here, we've got a Pac-Man looking shape, and the area for this one. Now, I've been given that angle there. I want to know the interior angle of this shape. So how do I work that out? Well, that's going to be 360 degrees, take away that 80, and what does that leave me with? That leaves me with 280 degrees. So for the area, I've got 280 degrees out of the total 360, and that's pi times r squared for the total area, so pi times 4 squared. So that gives me an answer of 39.10 if I round it to 2 decimal places. That's centimeters squared. And then for the arc length, so the arc length is the arc length here. Okay, I've got the same fraction. I've got 280 out of 360 degrees. Now I'm timesing it by 2 times pi times r, which is 4. So that gives me 19.5 0.55 centimeters. Okay, so that will be the arc length. Sometimes they ask you in questions not just for the arc length, but they ask you for the total perimeter. So if I wanted the total perimeter, I'd have to add on these two extra radii. Okay, I'd have to add on a 4, and then I'd have to add on another 4. Okay, so that is a quick look at arcs and sectors.
Joash Maths.